These are notes for Algebra 1, 4.6, and we're going to keep solving systems of equations. And this time we're going to use what is known as elimination. Now, I just want to do a quick review about systems of equations and just remind you that a system is two or more equations and they have two or more variables. And a variable, as you know, are placeholders for numbers. They're symbols. We use X, we use Y, we use all kinds of other letters. Sometimes we'll even put, a smiley face in there as a placeholder. But most of the time we're going to use X and Y. Now, what we've been doing so far is called solving by substitution. And what I want you to see is why we have to substitute in order to solve. Here's an example of a question that we've done previously. And you'll notice that the two equations, there's two equations and there's two variables. So it fits the definition of a system, which is two or more equations with two or more variables. Now, if I wanted to solve these equations to find out exactly what y is and exactly what x is, that means what is the number that we need to put into that equation, it's impossible to do when you have both variables. The only way I could figure out what y is in this first equation is to actually give x a value. If I said x equals 3, well, now I could substitute and say y equals 3 plus 4, and we know that y equals 7. Okay, well, what if I said x equals 10? Then I substitute 10 in for x, and I say y equals 10 plus 4, and so y equals 14. But I have to substitute to make that x go away. Because if there's an x and a y in the equation, there's no way for me to solve and actually get a number. Look at the second equation. Like we could subtract 4x right here, and so now we have y equals 4x plus 24. Well, that doesn't solve anything. All it does is tell me that y is on the left, and until we put some value in for x, we're never going to know what y is. Or until we put some value in for y, we'll never know what x is. But all I can do is just keep moving the letters back and forth. I could, we subtracted 4x, so we have y equals negative 4x plus 24. Well, maybe I could move it back, add 4x, but I could never make them disappear because there's always two letters there, and until we know the value for one of them, meaning a real number, until I have a number to put in there, I can't solve the other one. So that's why we use substitution. When I say y equals x plus 4, and I substitute that in for y in this equation, now I have 4x plus, and instead of y, we're going to substitute x plus 4 equals 24. Well, now you notice the y is gone. The only thing I have left in the equation is x's. So I have 5x over here. These are like terms. 5x plus 4 equals 24. And now I subtract 4, and I get 5x equals 20. And we can divide by 5, and looky there. I was able to figure out what x is. We have a value, and the way I was able to do that was by making one of these variables go away. And so now that I know that x is 4, I can plug that back in, and we're going to make that variable go away. So we have y equals, and I'm going to substitute 4 for x, 4 plus 4, so y equals 8. So in both cases, we made one of the letters disappear, and that's what enabled us to solve the system of equations. Okay, so that's just a little review of what we've been doing. Today we're going to do a lesson called elimination. And so we're going to eliminate one of the variables, only we're not going to do it by substitution. We're going to use a different method. So I'm going to introduce this lesson to you by looking at your notes here, and there's 6 sets of equations. We have 6 different systems. And what it's saying to you to do is to combine each pair of equations, which means we're going to add the 2 equations together. So it's like a little a little math problem. I'm just going to put a line under here, and we're going to add them together. We're going to take 2x, the first term, 2x plus x. If I have 2x plus 1x, I've got 3x. And now I have negative y plus y. Uh-oh, those are opposites, so they cancel each other out. And then negative 1 plus 7 is 6. So you'll notice the y got eliminated. Okay, let's try the next one. All we're doing is combining these equations. I have 3x minus 2x. So if I put 3x minus 2x, I have 1x. Then I have negative y plus y. Oh, those cancel out. And then negative 2 plus 3 is going to equal 1. So we're just adding the two equations together, and so you'll notice the y disappeared. And now on the next one, we have 4x plus x is 5x. And then I have positive y plus positive y. Okay, now on this one, we have 1y plus 1y. That's going to be 2y's equals 22. And nothing disappeared on that one. We still have an x, we still have a y. Now I want you to add the other three. Try and do that without my help. See what you can do. Add those equations together and hit pause and do it yourself. Okay, so let's take a look at your answers on the number 4. We have 3x plus 5x is 8x. 1y plus another y is 2y. And negative 6 minus 10 is negative 16. So we have both x's and y's left on this one. On number 5, negative 3x plus 3x cancels out. Y plus 5y is 6y. 15 plus 21 is 36. So we end up with 6y equals 36. Okay, on number 6, we have a half an x, and then we add another half an x. That makes one whole x. Negative 5y plus 7y is 2y, and then 30 plus 6 is 36. So in all 6 of these equations, we've just added the two equations together. Now it says, circle the equations in which one of the terms was eliminated. So on this one, the y was eliminated. On number 2, the y was eliminated. Nothing was eliminated here. Nothing was eliminated there. And here, the x was eliminated. And then on the last one, nothing was eliminated. So it says, how then could we use elimination as a method for solving the system? Well, since the let's look at question 1. Since the y was eliminated, now we can go ahead. Oops, I erased more than I planned. We can go ahead and solve this. Divide by 3, and we know that x equals 2. And now that I know that x equals 2, just like we did in substitution, we can take that 2 and plug it back into one of the original equations and solve for y. So I could plug it back into, let's use the second equation. I could say 2 plus y equals 7, and we subtract 2 from both sides, and we get y equals 5. So there we go. We've solved this system, 2, 5. And we did it by eliminating the y's. Okay, on number 2, the y's were eliminated, and we already have x equals 1. So go ahead and use that equation, plug it back into the original. And so I'm going to plug it back into the second equation. So we would say negative 2 times 1 plus y equals 3. I'm plugging this 1 in for the x right there. And so then we have negative 2 plus y equals 3. Add 2, and you get y equals 5. So we've eliminated, by eliminating the y's, we were able to solve for x, and then once we had x, we were able to get y. So we have 1, 5 is the solution. Now, on question number 3, there's nothing I can do. I can't solve for x or y because we haven't eliminated one of the variables. Same thing with number 4, can't solve. But on number 5, I can go ahead and divide each side by 6. I get y equals 6. And once I know that y equals 6, plug that back into one of the original equations. I think I'll go with the second equation, 3x plus 5 times 6 equals 21. So we get 3x plus 30 equals 21. Subtract 30. And you get 3x equals negative 9. Divide by 3, and x equals -3. So there we've solved that system. It's -3, 6 is the solution. Okay, so we did all of those, and let's go to number 6. On number 6, I can't do anything about it because we still have an x and we still have a y, and we can only solve to get a real value if there's only one variable left. We have to make one of the variables go away. So can't do anything with that right now. Now, let's take a look at what it says at the bottom of the page. It says, now what about the problems that you did not circle? Is there a way to use the elimination with those? There is a way to do that. I'm going to show you. Let's see. Let's take a look at them. We're going to go back. And I'm going to erase a lot of what we have here because it's a little messy. So, okay, these are the equations that we did not circle. Number 3, number 4, and number 6. Now, I'm going to take off what's there to begin with. And let's look and see, how could I do elimination using these two equations? Well, what we have to do is figure out a way to make one of the variables eliminate. And remember, in order to do that, you have to have one of them be positive and the other one be negative so that they can cancel each other out. So, for example, on number 1, we had negative y, positive y. This was negative y, positive y. Negative 3x, positive 3x. That's what made them eliminate. So if I could take, let's look at this equation right here. Let's say I multiply everything by -1. Remember, if you do something on one side and also do it on the other side of an equation, it doesn't change anything. So if I multiplied everything in this equation by -1, I would have minus x minus y equals -5. Now I'm going to put the other equation right on top of it up here. 4x plus y equals 17. Now when I add the equations together, 4x minus x is 3x. Y plus y is eliminated. 17 minus 5 equals 12. Divide by 3, and now I was able to solve it by eliminating the y. But what I had to do is multiply everything in the equation by the -1 to make it disappear, to get these y's to be opposites. So now once you have the x equals 4, you can plug that back into the equation. We do 4 plus y equals 5, subtract 4, and you get y equals 1. So we have 4, 1 is our solution to number 3. Now, how about number 4? What could you do to this one to make something disappear? Well, you could multiply the top equation by -1, or you could multiply the bottom equation by -1. Either way, it'll make one of these y's be positive and the other be negative. So I'm going to multiply by -1 the top equation. And I'm going to put my answer right down here, right below here. -1 times 3x is -3x. -1 times y is -y. And -1 times -6 is +6. Okay, so now let's put the two equations together. 5x minus 3x is 2x. Y minus y cancels out. -10 plus 6 equals -4. Divide by 2, and x equals -2. Bam! And there we've used elimination. Now that you know that x equals -2, plug that back into one of your other equations, and you can solve for y. So let's do that. If x is -2, let's say we say 3 times -2 plus y equals -6. So that means -6 plus y equals -6. If I add 6 on both sides, that says y equals 0. So the solution to this one is -2, 0. Bam. Okay, now let's look at number 6. Why don't you think about what you could do to make one of those variables eliminate? Think about that. Okay, so what I'm going to do is I'm going to take this bottom equation, I'm going to multiply it by -1. When I multiply it by -1, I end up with -1/2 x minus 7y equals -6. Now we're going to add that. I'm going to take this top equation and bring it down here just so we can see it a little better. 1/2 x minus 5y equals positive 30. So let's add the two equations together. Well, when we do that, the x's cancel out. Negative 7y minus 5y is going to be negative 12y. And negative 6 plus 30 is 24, positive 24. So divide by negative 12, and y equals -2. And now that I know that y equals -2, I can plug that back in to one of the other equations. Let's, how about we do it in the first equation? We have 1/2 x minus 5 times -2 equals 30. So I have 1/2 x plus 10 equals 30. Subtract 10, and I get 1/2 x equals 20. Now at this point, you need to divide each side by 1/2, or you can go like this. The opposite of dividing by 2 would be multiplying by 2. Either way, you're going to get the same answer. If you took 20 and divided it, by 1/2, you're going to get the same thing as if you took 20 and multiplied it by 2, which is 40. So these 2's cancel out, and we get x equals 40. So 40 comma -2. And there you go. That's the solution to that system. On all of these, we've eliminated a variable in order to solve the equation. Okay, so let's move to the back of our paper. And so on question 7 and 8, it says, can we use elimination method to solve these systems? Well, let's take a look at them. Well, one thing I notice is that the two equations are not arranged the same way. On the top equation on number 7, we have a y, 3y, and then an x. But on the bottom one, we have a x and then a y. Well, that's easy enough to solve. Let's just rearrange one of the equations, leaving everything exactly the same signs, whether it's positive or negative. We're just going to put them in a different order. So if I leave the top equation the way it is, 3y plus x equals 11, but if I take the bottom y and instead of -x plus y, let's do y minus x. Haven't changed anything, just changed the order that the letters were in, equals -7. Now let's add the two equations together. We'll combine them. 3y plus 1y is 4y. The two x's, they cancel out. And then 11 minus 7 is 4. So we divide by 4, and we get that y equals 1. Now that I know y equals 1, we can plug that into one of the other equations. So I'm going to take it and put it in for the first equation. 3 times 1 plus x equals 11. So it's 3 plus x equals 11. Subtract 3, and we get x equals 8. And there we've solved our system of equations. It's 8 comma 1 is our solution, and we did that using elimination. Now let's look at number 8. It's a little more tricky. Well, let's see. It's not arranged the same way. If I were to take the first equation and leave it as it is, 6x plus 2y equals 32. And if I were to rearrange the second equation, I get 5x plus 2y equals 28. I still cannot eliminate because, remember, in order to eliminate a variable, there has to be one that's positive and one that's negative. So even though we've rearranged, the y's are still the same sign. And remember, one of them has to be positive and the other has to be negative. So how about we take this equation on the bottom and multiply it times -1. And remember, when you multiply by -1, the only thing that happens is the signs change. So this one's going to become minus 5x. This is going to become minus 2y. And this is going to become minus 28. So now we can combine them. 6x minus 5x is x. Plus 2y minus 2y cancels out. And 32 minus 28 equals 4. So x equals 4. And now we can plug that back into one of the equations. So I'm just going to use the first equation. We'll do 6 times 4 plus 2y equals 32. And so we have 24 plus 2y equals 32. Subtract 24. 2y equals what? What does that equal? Equals 8. And so we divide by 2. And y equals 4. So our solution to this system is 4, 4. Both x and y are 4. And there we go. Now, got 2 more questions, word problems. So we're going to use this concept and set up some problems and solve them. So number 9, it says, I'm thinking of 2 numbers. Their sum is 23 and their difference is 9. What are the 2 numbers? So let's think about this. When we see the word sum, that means we're adding. And when we see the word difference, we see we're subtracting. So we've got to figure out 2 numbers. It says, what are the 2 numbers? So let's go ahead and write some let statements. So we'll let x equal a number, and we'll let y equal another number, or the other number. And so their sum is 23. So x plus y equals 23. And their difference is 9. So x minus y equals 9. Well, this works out nicely because we can see the y's are going to cancel out. So x plus x is 2x. Y minus y cancels out. And then 23 plus 9 equals 32. So we divide by 2, and we get x equals 16. Okay, so now that I know that x equals 16, I can plug it back in. And I'm going to use the first equation. So we're going to put 16 plus y equals 23. And so we subtract 16 from both sides, and you get y equals 7. So our solution is 16, 7. Now, if you want to just double check your work, let's look. Does 16 plus 7 equal 23? Yes. And does 16 minus 7 equal 9? Yes. So our solution works in our problem. Okay, let's try the last problem. Julie went to the Texas Tornado hockey game and bought 2 hamburgers and 2 Cokes for $5.36. And she bought Angela bought 3 hamburgers and 2 Cokes for $6.85. What is the cost of 1 hamburger? So, look, we are dealing with hamburgers and Cokes here. So how about we let x equal the hamburger, and we'll let y equal the Coke. And now let's set up 2 problems. 2 hamburgers, so that would be 2x, plus 2 Cokes, that's 2y, equals $5.36. The other one is 3 hamburgers, so 3x and 2 Cokes, 2y, equals $6.85. Okay, so now we'll notice that, remember, if we want to use elimination, one of them has to be positive and one of them has to be negative. But, so these are both positive 2y's, but we can multiply, and make one of these negative. So I'm going to multiply this one by -1. So remember, when we multiply -1, the only thing that happens is the signs change. So I'm going to put minus 2x here, minus 2y equals minus $5.36. So when we do that, see the y's cancel out, and we get 3x minus 2x is 1x equals $1.49, and that's going to be the cost of the hamburger. And then when you plug that back in, I'm going to plug it back into this equation right here. 2 times $1.49 plus 2y equals 5.36. So you get $2.98 plus 2y equals 5.36. And we're going to subtract then. And we get 2y equals $2.38. And so we divide by 2, kind of running out of room. And y equals $1.19. So a hamburger is $1.49, a Coke is $1.19. And the question said, what is the cost of one hamburger? And here it is, $1.49. Bam! Okay, that's it. That's using elimination to solve equations. So I hope that's a method that you like. And as we go forward, you'll see you can use whatever method you want to solve systems of equations. Elimination is just one of them. So we'll see you in class. Good luck.